Good morning, everyone. This morning we're going to cover a topic that not too many people know about, and we're going to go into it in some detail. This is a transport technology that has existed for some time, but doesn't have wide distribution yet. And I think once you see this presentation, you'll wonder, like I do, why we don't see more of it. It is a wonderful way to transport your data with a tremendous number of benefits. Most importantly, savings in CapEx and OpEx. But before we get into that, I want to give you just a very brief one-slide description of who we are. The optical and IP side of Ribbon has a number of products that you may not be aware of. Down in the middle of the screen, you'll see Apollo on the left-hand side. This is traditional optical transport and OTN switching products, and of course that's where we'll be spending our time this morning. We also provide Layer 2 and Layer 3 switching and routing through our Neptune platform, designed organically in-house to work with our other products. And Lightsoft is unified management, a single pane of glass. Everything that I talk about from the IP optical side of Ribbon is controlled through the Lightsoft interface. So it is truly unified in that respect. And then finally, Muse is our SDN automation and orchestration suite. And lots of activity in that arena as well. So this is a very quick, high-level, broad but not deep overview of what we do here at Ribbon. Like I mentioned, we are going to be spending all of our time speaking about Apollo, and specifically about OTN switching. So first, we're going to talk a little bit about OTN because virtually everyone's heard of it, but really, what does it mean? What does it stand for? What does it mean? And specifically, when we talk about OTN switching, what specifically does that mean? How does that work? So OTN is a standard that was designed by the ITU in the standard G.709. And without getting too deep into the weeds on the technical specifications, it's essentially creation of containers that we can then put payload in, right? The benefit of this is that with the various sized containers, we can put various sized payloads in there, excuse me. So in the smallest containers, you can put 1 gig or sonnet type data. In the larger containers, going up to 2.5 gig, obviously that's about an OC48 size. There's a 10 gig container, 40 gig. Not many people use 40 gig these days, but the standard is there. And then there's 100 gig, a 200 gig, and it actually goes larger than that. So think of these as shipping containers, right? Because that's really what they are. The purpose of OTN and the digital wrapper, if you will, the container, is that I can put anything I want in that container and then put it on a train or a ship or what have you, and then have it travel that route. And at the end, then there's a big crane that takes all those containers off, and we get the contents out, the payload, if you will, right? That's what OTN is in a nutshell. So as you see, there are different sized containers. They do fit within each other, right? They were designed to do that. So you can put, for instance, 4 OTU1s into an OTU2. Then you can do 10 OTU2s into an OTU4. You can put a pair of those into an OTU2C, and so on. So it lends itself very well to multiplexing various types of data together, It can be SONET, it can be Ethernet of various sizes. We can do fiber channel. There are video signals we can put in these. They're really very flexible in terms, just like like my analogy, like a shipping container. So you pack them full, and then you can build these larger containers, OTU2, OTU4, OTU2C. And the benefit, of course, here is that we can more fully fill that wavelength, right? So the whole purpose here is that we put containers, small containers into bigger containers, and we don't leave any empty space, so we don't strand any bandwidth. So here's a quick graphic on how that would work. So, you know, traditionally, here's how you move data. You've got Ethernet, you've got SONET traffic, you may have fiber channel, etc. Each one of those, of course, runs on its own wavelength. They may be DWDM wavelengths, they may be wideband gray wavelengths, but each one taking up its own wavelength. And of course, each one of these may not be running at 100%. So if I've got an OC48 signal, I may only have 3 OC12s in it, right? So I've got empty space there. So the idea of OTN containers is that I can take all of these signals on the left-hand side. So these all fit within an OTU1. Gigabit Ethernet, OC48, 2 gig fiber channel, all of those fit within their own OTU1 containers. And so with an OTU2, I can put it on a single wavelength. I can remove all of those individual wavelengths and then put these containers onto the larger signal. Okay? So one thing to keep in mind is that the integrity of the OTU1 containers, for instance, the one holding the OC48, right? The integrity of that container is still there, right? So I haven't had to empty all 4 of these boxes and dump them into one big OTU box, right? Each one of those gets placed within the OTU2, and then later I can go in and individually and specifically pull one of those containers out and distribute it. In this way, I can run this OTU2 around my network and then drop and continue anything within that signal, right? So very, very flexible. You take your multiple subarray services and you put them all into a single wavelength, right? It's much more efficient use of your wavelengths. Now I've got a single wavelength instead of 4. That, of course, means I've got one optic to buy. I'm using one port interface on a card instead of 4. Which, you know, obviously will improve your CapEx. Okay, so now that I've got my OTU container train filled, right, what does that buy for me? Well, we've seen some of the benefits already, but this technology, as I mentioned, is extremely efficient in terms of doing that multiplexing before you even get to the line side interface. And so I'm much more efficient in terms of the number of ports I'm using, the number of optics I have to buy, and so forth. Also, because this is a layer 1 technology, it's extremely low latency, right? So it's really fantastic to move your data, your payloads from one side of the network to another, even moving, excuse me, my slides keep wanting to advance. Moving traffic even through a dense or mesh type network where I have to hit a lot of nodes, because the pass-throughs at each node are all optical. I don't have to drop any containers out and do any resorting and remuxing. If I'm not using or if I'm not dropping that particular container, then it passes through at a low latency fashion. This is an incredibly resilient and reliable solution. We've got, at layer 1, we've got a number of protection technologies that allow us to do a sub 50 millisecond switching. These are intelligent technologies as well that let us not only survive a single, and I apologize for that, it does keep wanting to go. The protection technologies are intelligent such that a single failure can be overcome, but then if you get a secondary or a cascade of failures, then it can continue to evaluate and continue to reroute that traffic, even if it means switching channels, right, within a DWDM solution. It has all of the network at its disposal in order to keep that traffic moving forward. It's really one of the more advanced types of protection that's available in networking today. Of course, it's OTN. Part of the OTN standard is forward error correction, which gives us additional reach, which means less in terms of amplification on average that you have to spend. The solutions I'm going to show you here today are encryption capable. We use AES 256, really one of the highest, if not the highest, encryption standards out there. This encryption is done at layer 1, so, and on a per service basis, so that you can sell that service to your customers for healthcare, for other critical infrastructure that needs a secure and encrypted link. And I talked a little bit about the fast rerouting and protection. Excuse me. Okay. There we go. Okay. So the OTN switching evolution. So as many of you I'm sure have seen or have in your network, you do have OTN. But what you're seeing is an OTN encapsulation that is used primarily for the forward error correction. Just about every network interface these days, particularly in DWDM networks, has an OTN encapsulation on that line side port. So it's the same OTN, right? But it's not OTN switching. What it is the encapsulation that is used for simple point-to-point transport, and then the encapsulation is stripped off at the other end and the payload is dropped off. So that is using OTN encapsulation. However, like I said, it's mainly using it for the forward error correction and the additional reach that provides you. What we're doing in OTN switching is we are leaving things in those containers until they get all the way to the final destination. And this technology, when it first came out, was really kind of limited to the core. You had half rack and full rack solutions, and it was a really kind of a tier 1, big spend, heavy iron kind of solution. What has happened, of course, over time, things get smaller, things get cheaper, and the technology extends further out into the network. And so today, we've actually got solutions that are 1 RU in size, very cost effective, and can either stand on their own, or as you see at the bottom, can interoperate with Metro and core OTN switches as well. The other point I want to draw here is that when I configure, say, a large interface, a 100 gig, which we call an OTU4, or a 10 gig, an OTU2, then those are pre-provisioned interfaces. So I set up the line-side interface to, say, run an OTU2 for 10 gig. Well, then I've got a number of client ports that will automatically be assigned to that network port. And so anytime I want to, I can plug in those subrate interfaces and they will automatically map to the network interface, right? Thus saving you a fair amount of time in configuring your network. That, of course, extends to the 100 gig, 200 gig, and even larger OTN interfaces where you can pre-map your traffic patterns, and then the only thing you have to change as you do moves, adds, and changes is either plug or unplug customer access pluggables, right? So there's a fair amount of work that is saved for you once you've built the network, you've built these provisioned network interfaces, and then you continue into production with your network. I'm going to hit this one again, probably hit it again before we're done. Because I can mix and match all of my payloads, I can put SONET on the same wavelength as Ethernet, as the same wavelength as fiber channel, and so forth. That means I can more fully use or more fully pack my wavelengths out on the network. Fewer wavelengths means I have to buy fewer of those really expensive DWDM optics. What you see there in the second to the last bullet, ASON, is automatically switched optical network, and that's the actual name for the protection scheme that I described on the last slide. And this technology allows us to map the network and then determine all of the possible paths to switch traffic, not just for the first failure, but the second and third and so on. These switches take place sub 50 milliseconds and obviously can be a real game changer for your network. One way we describe this is it's a self-healing network, right? There are a number of protection schemes that let us survive a single failure, but what about multiple failures or even a cascade, right? And that's where ASON really comes in handy. And that runs from the access all the way to the core. Okay. So here are the devices that we employ here at Ribbon to provide this service. They run just like you see in the diagram, right? They run from the access all the way up to the core. The 9932 on the right is a full rack solution. That's the heavy iron, right, that I was mentioning. But the technologies, everything that the 9932 provides for us, are available in all of the other chassis, even down to the 1RU 9901X. And we're going to talk in more detail about that platform because it has particular value. I would say more value if I were going to choose one of these platforms. It's probably the one that has the ability to make the largest impact on your bottom line, not just in terms of services that you could deliver, but in the efficiency of your network and the reduction in costs. Again, these are all multi-service, so I can run any type of service that you're currently running on your network today within OTN containers. The network side interfaces scale all the way up to 400 gig. That's not necessary everywhere, of course, but where you've got a core network that is aggregating, dozens of 10 gigs, perhaps multiple 100 gigs, then those larger interfaces really come into play and become a lot more efficient. I've talked about encryption. We'll talk about that towards the end of the presentation and provide more data for you. This is also a platform that we have had involved in the Tier 1 Open ROADM initiative that you may be aware of. Multiple vendors, all of the vendors in our space, as well as the big Tier 1s here in North America are involved in a white box and Open ROADM solution where the idea is to get us all working together. It's an initiative that has been in play for quite some time, but they're making great strides on there, and we were invited to employ our OTN switching within that test bed. Okay, so just a few numbers here for you. So the 9901X, if you'll direct your attention to the upper right and this table. So the 9901X is a 1U shelf It's got an OTN switching backplane of about 400 gig. And like I said, we'll take a closer look at that here in a moment. And then you can see the larger chassis. The 9904 is more of a hub or aggregation site device, 5 RUs and about 2.8 terabits. And then there's the half rack and the large rack solutions, which really become truly massive. Okay, so go to the next one. This is what I like to call my whiteboard slide. Typically, we use this one to answer Q&A, and so we may come back to this slide later as you ask your questions and we talk through the actual practical side of employing this technology. So if you look in the upper right, this is the 9901X. As I mentioned, it's a 1 RU box. It is, you might call it an appliance, meaning that it's not modular. There are no cards to insert here. There are cages for pluggables. And it's really a great mix of capabilities in a very small and cost-efficient package. So the first thing I'll direct your attention to is the orange box here. So this is a pair of OTU4s, which you may recall, that's the 100 gig container. These are QSFP DDs, and this allows us to go 100 gig both east and west out of a single chassis. So in a simple access type ring like you see here, we're going east and west out of a single shelf at an OTU4 or a 100 gig rate. If these spans are greater than 80 kilometers, then I can actually plug in amplifiers here and give us some extra reach. That's with DWDM optics, of course. If you have short spans, say 40 kilometers or less, then your gray optics, which are much less expensive, can also go in this shelf. So very flexible in terms of how it handles the line side connections. For the client side, there are 20 SFP and SFP plus ports. So these are, I'm sure, very common to all of you in your networks today. They use standard off-the-shelf pluggables. And this is where you can plug in really anything you need to. You can plug in gigabit Ethernet, 10 gigabit Ethernet. You may have OTN framed traffic that needs to be multiplexed into an OTU4. And then, of course, we can handle virtually any sonnet out there from OC3 to OC192. And all of those plug in, and then in OTN switching fashion, they are multiplexed into an OTU4, which is then sent down the line. So very quickly, you've got, say, in the upper right here, we have traffic that comes on, which is Ethernet and or sonnet. It gets multiplexed into an OTU4, and then we pass it around the network. We can pass it in both directions. And then depending on where that traffic needs to drop, that's the only place where you will need to reach into that OTU4 and drop out that signal, right? Drop out that smaller or sub-rate container. If it doesn't drop out at any of these sites and it needs to go up here to the hub site, then we can run it in a protected fashion around the ring, east and west. And at the 9904X, which you see at the top as the aggregator, if it needs to drop there, great, we can reach in and drop that container out. If it doesn't need to drop there and it actually needs to go onto the core where it is hitting a server farm or what have you, then again, no demultiplexing needs to take place. All of that is optical pass-through, very low latency, and then, of course, protected with your choice of a number of protection schemes. So very, very practical. Particularly in a situation where you've got an access ring, you've got legacy sonnet, you've got Ethernet. Obviously, we want to packetize everything that we can these days because it's much cheaper. There are very few sonnet boxes that are out there today that are new, and of course that technology is obviously going away. And so the ability to take not only Ethernet but that legacy traffic and then move it very efficiently over a single wavelength, and then drop it off where it needs to be is a huge differentiator for you. Okay, so let's talk, now that we've kind of talked about general architectures, let's talk about the business services, the business value of how this is going to come together, and specific value to your enterprise. So generally, what we have and what you've seen in my presentation so far, and I'm sure what you have in your enterprise, is you've got multiple interfaces. Most of them are going to be at low speeds. That's where the bulk of the numbers of the interfaces are at your in your network, right? And they range from, you know, legacy TDM all the way up to, well, in this case it shows 10 gig, but it could be even larger than that, right? So being able to combine as many of those as possible into a network interface that is right-sized for the location, be it 100 gig, 200 gig, 400 gig, even 10 gig, right? You may have locations where you've got a handful of T1s and you've got 3 or 4 1 gigs, and you need to combine all those into a 10 gig. That's obviously a part of this as well, right? So I don't want to mislead or falsely imply that everything has to run at a multi-hundred gigabit level. The technology extends all the way to the lowest level. Okay, so being able to groom all of those and to do that in a deterministic manner, meaning that I know exactly where my traffic is going. There's no cloudiness to this technology. There's no goes into and then goes out, and you have no idea what's going on in between. This is what we call a deterministic technology, where you will be able to map your traffic patterns exactly, so you know what fiber runs you're using, which fiber runs you're avoiding, and if you have issues, you're going to know at a glance exactly what traffic was on the link. I've talked before about reducing the stranded bandwidth. The chart in the lower right, it really kind of illustrates that. So what this means is, to just kind of decipher the chart for you, is that if you are not using OTN switching, then what typically happens is when you have a new service that needs to go on, rather than going back and looking at existing wavelengths and figuring out where I can put this to better use those wavelengths, we just turn up a new one. After all, I've got 48 of them or 96 of them. It's kind of an embarrassment of riches, right? And so we just turn up a new wavelength. Well, maybe we're not using that wavelength or the existing wavelengths at their full capacity, right? So if you look at these two lines, this illustrates, the blue line is what happens as you start gaining services and you start turning up your individual wavelengths, right? You start using more and more and more wavelengths. However, with OTN switching, the orange line, you are going to use a fraction of those wavelengths because we're packing them more fully and letting you get the most out of your investment. If you're spending several $1,000s on a DWDM optic, you want to get the most out of that wavelength that you can, and OTN switching is the way to do that. The bottom line is, this is a technology that really is a game changer in terms of low cost of entry, cost effectiveness, not just initially, but over the long term, because you're going to get a lot more value out of your existing transport gear. So here's an example in a traditional DWDM solution and I've kind of been referring to this. This is where you have a service and you turn up a wavelength, and then you get another service and you turn up another wavelength, and so on. So some of you or all of you may be very familiar with this type of architecture where I've got multiple DWDM nodes around a ring. At each one of those sites, I've got customers or an aggregation of an access ring, and then I put a fixed fixed filters in. I put transponders and muxponders to handle all of that. The challenge here is that this is a network that is really designed for the way we did business 10 years ago, right? And these don't age well as you grow. If there's not any growth, then obviously once you put it in, and if it's working for you, great. But the difficulty is over time, as you grow, as your pipes grow in size, as they grow in number, you're still dealing with your legacy traffic. You know, in the non-OTN switching world, for your legacy TDM traffic, for your fiber channel traffic, you're having to put in a different card, a different muxponder, and so forth to format those and put them on their own wavelength. OTN switching, of course, removes all of that and creates just a simple OTN switch at each location, right? Very easy to use. There's no guesswork. All ports accept all data types, all payload types. The service provisioning, as I've talked about before, is pre-mapped, right? Pre-provisioned. So I have a single wavelength down here at the bottom. I've got a single wavelength that's been configured. Obviously, I can do multiple wavelengths if I wish for protection. But then I've got a wavelength that links up my access switches here. So anything I plug into this is going to drain out to the core network if I wish it to, right? So all of this pre-provisioning means when it comes time to turn up a new service, it's very easy. It's plugging it in and then making sure that you're hitting the right outbound wavelength. Very, very straightforward. Encryption we're going to talk about. I've already talked about the protection schemes and the self-healing network. So that point kind of stands on its own. Okay, so this is, I'm not going to go through every bullet point here. This is a wrap-up slide or a value proposition slide. This basically is for you. We're going to make this available to the audience so you can go back and read at your leisure. Some of these are restatements from what I've talked about here before, but what I will do is direct your attention to the large blue box at the top, right? So the flexibility of an OTN switching solution once it's in place really lends itself to maximizing your investment, right? And rapidly increasing, or I should say rapidly advancing you to where you are getting that return on your investment, right? That's really what it's all about. The technology is fairly new, but the building blocks of it have been with us for a long time. It's simply data transmission over wavelengths very efficiently. The benefits are generally that flexibility as well as its simplicity, right? We've got fewer moving parts. I don't have multiple cards for multiple payload types. I'm certainly not running multiple wavelengths, spending the money on those DWDM optics. What I'm doing is simplifying all of this, right? Simplifying your Layer 1 transport network. Also want to be clear that I'm not suggesting that OTN switching is a complete replacement for Layer 2 and Layer 3 switch routing, right? You know, my personal philosophy is that each one of those technologies is appropriate in a particular part of the network. Obviously, there are features within Ethernet that you don't get in Layer 1, right? That's why we have Ethernet. Routers should route, and they should be in an appropriate place in the network. But using the appropriate tool in the network where it makes the most sense and where, quite frankly, it can make the biggest impact to your bottom line, that's what OTN switching is all about. It's lowering costs of ownership. Okay, so I just wanted to throw this one in as well towards the end of my presentation to illustrate that the 9901X, that small OneRU OTN switch is really uniquely positioned for a number of applications, one of which can be simply linking up multiple customer locations. So obviously we can pull the data off of these devices and bring it into your carrier environment to provide them with their internet traffic and other value-added services that you might be offering them. But it's also a great application. It's a great device to let them link up their own locations, right? So it can provide that CPE, that inter-customer or intra-customer access device, right? It's priced at a price point that makes that attractive. And of course, if you've got multiple data sources and it needs to be simple and plug and play, then obviously it lends itself to that as well. Okay. And I mentioned encryption a couple of times. Some of you may be nodding your head, yes, this is interesting. Others of you may say, well, I've never had a requirement for encryption. So let me just interject a few things. So there are a number of new legislative initiatives out there that are going to make encryption that much more important. Of course, we're all familiar with the need to protect healthcare or HIPAA data from end to end as it goes through our networks, right? A number of government agencies with the Homeland Security emphasis are now looking at encryption to protect their data as it transits across our private networks. And then finally, with the advent of ransomware, you've got cities and large enterprises that get hacked and their data gets held for ransom, and there have been millions of dollars, unfortunately, paid out to these hackers who simply tapped into a line, got what they needed to log into a network, and then they took control and shut it down. Encryption prevents that, right? A tap, which is actually fairly easy to come by, it is not going to yield anything to them. They'll get the data stream, but it will be absolute gibberish to them. And those of you that are familiar with encryption and how that technology works will understand that. So the keys are held obviously by the trusted members on either side of the signal. What our device does, what the OTN switch does with encryption is it will take anything on that line that you want to encrypt. So there may be data on there you don't need to encrypt. This can be a value-added service for your customers, of course. You can offer that encryption, let them turn it up for those services that they want encrypted, and then things that they don't want to pay for it, you don't have to turn it on for those, right? It is the very highest level of currently available encoding, AES 256. And it's fairly straightforward, right? It encrypts it, it turns it into gibberish across the line until you have the decode key. This all happens at layer 1, so it's very low latency. There actually is no additional latency or overhead required for this. So it is the most efficient way to encrypt your traffic running across your network. So something to keep in mind. It is not something that you have to purchase right up front. The cards are hardware capable. The devices are hardware capable. So at some point in the future, if you decide that you need it or you have a customer that's asking for it, it's as simple as turning it on. And this encryption goes across the entire line of OTN switches, all the way from customer access all the way through the core and then back out again, right? So it can be maintained in every one of our devices, really regardless of architecture or the shelves you've chosen to put in place. Okay, so in summary, on OTN switching, I hope I've given you a good feel for what OTN switching is. and why it's different, why it's a differentiator, why it can be. You'll notice that my little icons are the little man with his hand out for the money, right? It's really all about the money here. Are there other ways to move data in your network? Of course there are, right? But OTN switching is the most efficient and the most flexible, and can have the largest impact on your bottom line. Turning that, networks are always on the cost side of the balance sheet, right? But with value-added services and a much more efficient method of moving your traffic, not to mention handling your legacy traffic, then you can much more quickly get to that return on your investment when there's still years of life left on your equipment. And at that point, it's what we call making money, right? I'm not spending any more money on my network, and it continues to provide that service that I need. So with that, I think I will end my presentation. And Jamie, if there are any questions that perhaps have come in.
Yeah, sure, Jack. And I started to answer one of them in the chat, but I thought maybe you could expand on it. A couple questions related to outside plant hardening. And I provided the operating range for the 9901 of -5 to +55, which can work in some applications. But then there was further questions around, what about outside plant cabinets without any fans, or with just only a fan and a heater? Maybe you can talk about how it can work in hardened, and does that apply to all of the 99 series or just the 9901?
Yeah, so great question. So the 9901 is really the one that you probably will see most deployed out to a cabinet or a non-conditioned location. And Jamie did thank you for providing that temperature range. Generally, what we see is that, and then obviously it depends on where you are, right? Alaska versus Florida, but generally what we've seen is a very resilient and tolerant solution, particularly with a fan or a heat exchanger. I don't know that we have any of these deployed in cabinets with air conditioners. Yeah, I'd have to look at that. I don't think we do. So, that temperature range, as long as there's a heat exchanger in there, and then it's properly engineered, so we've got airspace around it, so those air can circulate. I would think we're going to be just fine. Of course, every cabinet is a new experience, but yeah, I don't see having to put an air conditioner on the outside of your cabinet.
Okay, and then there was another question around the optics or the pluggables. Depending on, do they all work in that range, or do you have to have specialized optics?
Yeah, so that range is the standard range for our standard optics, right? There are optics that are what we call industrial strength, or not industrial strength, but industrial temp or I-temp optics, right? And those are optics that obviously can go, I think the range is -40 to +60 or +65. Those are available. They're much more expensive. So it comes down to cost. What does it cost to put an air conditioner in there versus, if you're putting several vendors' equipment in there and they're all needing I-temp optics, then that cost-benefit analysis is worth taking a look at. Gray optics, in general, rule of thumb is the gray wideband optics, the ones that operate at 1310 or 1550. Those are much more temperature resilient. The more precise and high-powered DWDM lasers obviously are more sensitive to temperature. But as I mentioned, there are I-temp optics that are available if we run into a situation where we need them. Also, somebody had asked about the temperature hardening and does it extend to the other 9900 series. The 9904, I believe, is roughly the same temperature range. However, it's a 5RU chassis. It's generally not one that you would find in a cabinet. If you've got a much larger cabinet, then obviously we can put it in there. Again, it's more designed for a hub or aggregation site rather than an access site, which is typically where we find our cabinets. But never say never. It's got about the same temperature resiliency, and it's a 2.8 terabit switch. If you've got a need for that type of aggregation and what you've got there as a cabinet, then let's take a look at it.
Thanks, Jack. Another question around the 99 XX series cards. Are the cards compatible with the 9600 series Apollos?
Yeah, so no, they aren't. They're specifically designed for the 9900 series. That said, I didn't cover it here, but there are OTN switching blades for the 9600. I kind of focused my discussion on the technology of OTN switching here, and then in terms of our hardware, I looked specifically at the 9900 series. But for the person that asked that question, there are OTN switching blades for 9600s. If you've got those in your network and you're looking at potentially putting OTN switching in there, then let's talk, because that's absolutely available for you. The other thing, since we're kind of talking about the legacy, having necessarily a legacy, but you've got an existing DWDM system that is perhaps doing good service for you, but you want the efficiency and the flexibility of OTN switching. That works as well. The OTN switches, as I've mentioned, have DWDM optics in them, right? Or can use DWDM optics. And so if you have your existing transport system, be it an Apollo transport solution with ROADMs and so forth, or if it's another vendor's solution, and you're not quite ready to leverage forklift that out of there, and you're wanting to get a few more years out of it, then simply putting OTN switches around the periphery of your network and in the various aggregation sites, we can create an OTN switch overlay on your existing transport solution and give you all of the benefits I've been talking about, while allowing you to defer having to upgrade your DWDM transport solution. So that's another option that we can talk about.
All right, thanks, Jack. Next question, talking about long reach. Can we put 120 kilometer reach optics in there?
Sure.
Or is there an amplifier repeater only that could go in the outside plant cabinet to reach those longer distances?
Yeah, you bet. So great question. So specifically to the 9901X, there are ports specifically designed for the insertion of EFA amps if you need them. You can certainly put longer reach optics in there and perhaps avoid putting an amplifier on it. But if you need amplifiers, then you can certainly do that. The larger chassis also have that ability, right? So we can absolutely put standard optical amps and easily get you 120 kilometers. Matter of fact, we can go over 200 kilometers if we need to, using standard optical amplification, which of course we're really good at. That's one of the things we do really well. So long reach is not a problem.
And then we had a question around the different client interfaces and tributaries that we can support with the 9901. I don't know if it's easier to put the slide back up to talk through it, or
yeah, let's do that.
And also, I believe we've attached the data sheet on the product, which hopefully lists all the different interfaces as well that can be downloaded.
Yeah, there's a data sheet attached, and then I think Lance was also going to put an application note in there, which it's a bit of a white paper, if you will, but it's got diagrams and explanations very similar to the slide you see in front of you today, just talking about sample architectures and so forth. So here are the right here. 20 SFP, SFP pluses, Ethernet 1 gig, 10 gig, OTN encapsulations up to OTU2E, which is the one that we use for 10 gigabit Ethernet. And then from a TDM perspective, basically OC3 up to OC192. What is not shown on here is also fiber channel, so we can do fiber channel as well. And then there are, I don't have them on the slide, but there are various video signals that we can also accept and then put in an OTN container.
Thanks, Jack. And maybe you can keep this chart up for the next question. They were talking about different topologies that OTN applies to, and does it only apply to rings?
So, no, actually, it's flexible enough to really take on any topology that you've got out there. So, you know, this is a physical ring that you see here in front of you, but this also may be a mesh network. If there are multiple other fiber strands there, then we can work with those. Linear networks, you name it, right? This technology is applicable really to all physical topologies.
And I think there's a follow-up question to the 9900 versus 9600 asking about, you know, what is the basic difference between the 9900 platform and the 9600 platform?
Okay, yeah, good question. So the 9600 platform is traditionally the DWDM ROADM layer 1 transport, right? It's what you might call classic ROADM, classic transport. It provides the transponders and muxponders that you may be familiar with in your own network, and then puts those onto DWDM wavelengths to give you that force multiplier, right? DWDM is all about providing multiple wavelengths over a single pair of fiber so that you don't have to use up all your fiber plant, right? So that's traditionally what the 9600 is designed for, and it includes, you know, 4-degree ROADMs, 9-degree ROADMs, 20-degree ROADMs, as well as a wide range of line cards, all the amplification that you need, and the dispersion compensation, everything that we need to build you a network from 10 gig to 600 gig, right? It is within the 9600 series. The 9900, as I've been describing, is really the optical switch, right? So it's all about how it is taking client signals and then how it deals with those client signals. In some cases, you could replace a layer 1 9600 type network with a 9900 network, right? They do roughly the same job depending on your situation, the clients that you serve, and the services that you want to provide. The flexibility and the cost effectiveness of OTN switching can be a compelling argument. You know, there's no way to get around the value of DWDM, right? I mean, no one has come up with a way to equal 96 channels of 400 gig per channel, right? That sort of massive bandwidth is really only ever going to be available with DWDM. But what happens before we get to those big pipes is where the biggest impact can be made with the 9900.
Thanks, Jack.
Sure.
There was a question around provisioning and what are the provisioning options for this platform, and it's really unfortunate we didn't have time to talk about that, because I personally think that's one of the biggest benefits of the OTN switching and setting up circuits, but maybe you could address that.
Yeah. Yeah. So the provisioning on this runs through the LightSoft solution that I described at the very beginning of the slide. Very briefly, LightSoft is your single pane of glass management solution. It provides, let me get back to it, it provides us that one unified viewport, if you will, into what's going on in your network, right? So it's visibility of your fiber, it's visibility of the protection schemes that you've got in place. So the ASON or ASON self-healing network concept is employed, provisioned, and then viewable within Lightsoft, so that you can determine exactly which paths you want to use for your first failure, second failure, third failure, and so forth, or you can let the system do it on its own. In terms of provisioning for OTN switching, it's point and click, right? It's A to Z provisioning, where you start from your beginning node and you end at your where you need to drop that traffic off. My picture is a little small there, but if you can see the green and the red lines, basically what you're doing is you're looking at either your fiber layer or your layer 1 transport layer, your DWDM transport channel layer. You may, if you've got layer 2, if you've got our Neptune devices in, you're going to see Neptune Ethernet traffic, and then at layer 3, which Neptune also does, you'll see the routing logical layer as well. So you choose which layer you want to look at, and then that visibility is there, and the point and click provisioning is there as well.
Okay, I think we've covered all the questions. I'm reading through them. They were coming in while we were talking, but yeah, Jack, I think you covered them all.
Okay. Great. Well, I appreciate everyone's time. And I'll just, before I sign off and hand it back off, feel free, my email is available. Matter of fact, I'll put it right here at the end. Sorry for the rapid, there we go. There's my email address. Feel free to send me any questions you've got. More than happy to get on the phone with you and just talk engineering. If necessary, I'll bring a sales guy in. But if you just want to talk engineering and see what might be right for you, then I'm your man.
Well, thanks, Jack. Thanks, Jamie, for fielding those questions and replying to those questions. And thank you all for attending. We will be sending out an email later today with a replay of the event today, so you can check that out later if you have questions or want to revisit anything. Those two documents, the the OP9901X data sheet and the expandable OTN switching app note will also be in that email. So if you don't get those today or haven't had a chance to get those, you can download those from that email as well. And as Jack mentioned, reach out to us at these email addresses, or you can find more information at rbvn.com. And as always, look forward to the next webinar coming to you shortly. Appreciate your time today. Thanks so much.
Thanks.